All right, so welcome to today's class where we'll be looking at surds and rationalization. Okay, so when we talk about surd, okay, it simply means we are talking about square roots. Okay, so these surds here simply mean a number, okay, that is under a root. It can be a square root, it can be a cube root, it can be a fourth root, okay, it can be any other root that we can think of. Okay, but for your case, you are going to be dealing with square roots. Okay, so if we talk about surd, then we mean that we have a square root of a certain number. Let's say a there. Okay, or it can be a square root of b. So these here are what we are calling as surds. So the number under the root here, okay, the number under the root for us to call this one here a surd should not be having a perfect square root. So for example, if I say the square root of 4, we know that the square root of 4 is 2, okay? So this square root of 2 here is not a surd, okay? Because it has a perfect square root. What about if I have a square root of 9? Square root of 9, we know that it is 3. So this square root of 9 here, it's not a surd as well. Okay, so you can only be a surd if the square root does not have a perfect square. So let's say root of 2. So root of 2 here, you find 1 point something, 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 something. Okay, so this here won't be a perfect square root. So we say that 2 is a surd. Another example can be a 3. Okay, so a 3 is also a surd because it does not have a perfect square root. Okay, so the surds are just those numbers under the root that do not have a perfect square root. All right, so for you to be able to answer questions that will be coming under the topic surds, okay, you need to be aware of the laws of surds that we use. Okay, so the first one is a law that involves multiplication of surds. Okay, so when you are multiplying surds, for example, I have the square root of a, then I'm multiplying this by the square root of b. Okay, the answer here will just be, I'll write a big square root like that, and then I'm going to multiply whatever is under the root there. So that is going to become square root of ab like that. Okay, so that's the first rule. And then the second rule is the one that involves division. Okay, so when we say the square root of a divided by the square root of b, this here is the same as I write one big square root and then I divide a and b. So this is going to be a over what? B. Okay, and then the third one is when you're multiplying surds that are similar, okay, or surds that are the same. Okay, so we know that if we have square root of a multiplying by the square root of a again, okay, this here is the same as, so from this first rule here, we know that this here is going to become the square root of a multiplied by what? A, since we have a there and we also have a there. Okay, but when we multiply a multiplied by a, what do we get? We get the square root of a squared. Okay, so the square root of a squared is just a. Why? Because this square root here, okay, is going to cancel out with these two. So we're just going to remain with what? A. So whenever you're multiplying the square root of a certain number multiplied by itself, okay, it means these roots will just cancel out each other and just you're just going to remain with what? A. Okay, so if you have any questions, be free to ask, guys. Just unmute yourself and then you can ask. Right, so this is the third property that we should know, okay? This one here. And then the fourth one, okay, it involves a combination of the ones that we can see here. So let's create space for the fourth one. Okay, so we're going to say number 4. If you have surds, okay, let's say I have a, and then I'm multiplying by the root of b, and then multiplied by c, and then the root of D like that. Okay, so how can we simplify this guy here? We're going to multiply the numbers without the roots, okay, first. So it will be A multiplied by C. So I have AC, and then I'm going to say H big square root, and then I multiply this B and this D here. So I'm going to have B, D under the what? The root. So this is the rule that we are going to be using in case we have something like this, and then we are multiplying them. Okay. Okay, so those are the 4 roots, okay, that you should know when it comes to surds. Okay, so I've explained them. And then now let's explain what we call as rationalization. Okay, so if you have any questions, guys, be free to ask. So what is rationalization? Okay, so this word is intimidating, okay, but it's something that is very simple. Okay, so rationalization here simply means remove, okay, the square root or the surd. Okay, remove the square root or the surd from the denominator. From the denominator. Okay, this is what rationalization simply means. Okay, you just remove the square root or the surd from the denominator. So for example, if we have this number here, let's say I have 1 over the square root of A. Okay, and then you are asked to rationalize this guy here. Okay, so to rationalize, we just want to remove, okay, that square root that we can see here. We want to remove it from the what? From the denominator. So what can we do in order to remove that square root from the denominator? Okay, we are going to multiply by what we call as a special one. Okay, we are going to multiply by what we call as a special one, or they also call it as the conjugate. Okay, so I'm going to rewrite this. So 1 over, and then I have the root of A. And then I'm going to say this multiplied by, okay? So if in your denominator, guys, if you have just a single root like that, it's not added to anything, okay? It's just root of something. The conjugate of this guy is the same guy, okay? So we're going to multiply both this numerator and this denominator by the root of A. So we're going to say root of A multiplied by the numerator, even the denominator there, we're going to multiply by what? Root of A. Okay, so you can see that what we have here is a special one, because root of A divided by itself, it gives you what? 1. Okay, so what we are doing here, we're not changing anything. We're just multiplying by 1, but we are writing that 1 in a special way. Okay, yes. So if you just have one root like that, means the conjugate of this guy will just be the same guy. So you multiply this denominator with the same guy, and then the thing that you've multiplied the denominator with, okay, you also multiply this numerator with, so that you don't change anything. You just multiply by what? 1. Okay, so once we multiply that, what are we going to get? 1 multiplied by the square root of A, I'm going to get square root of A, and then divided by, okay, and then down there, remember those rules that we talked about. If you had root of A multiplied by root of A, this just becomes root of A squared, and then this just becomes A. Okay, so it means this root and this root are going to cancel if we are multiplying the same thing there. So here we are just going to write A. So when you look at the expression that we have here now, okay, we see that in the denominator there, we do not have a what? A square root. Okay, so removing the square root from the denominator is what we call as rationalizing the denominator. Okay, so don't be confused by the language. All right, so let me give maybe an actual example involving a number here. Okay, so let's say we have 5, and then we're dividing by the root of 6. Okay, and then they ask you rationalize the denominator. Okay, we're just going to multiply by the conjugate of this root. So if you have a single root like that, the conjugate is the same thing there. So we are going to multiply by, okay, the root of 6, and then even on top there, root of 6. Notice that this one here is just 1. So we are just multiplying this with just 1. Okay, so from there, we are going to say, okay, this is 6. We're going to say this is equals to 5 multiplied by root of 6 then divided by root of 6 multiplied by root of 6. It means the square root will cancel, so it'll just remain with what? 6. So we've rationalized this guy like that. All right, so this is the first type of question that can come under what? Rationalization. And then the second type is where you have a square root adding to a certain number or subtracting a certain number. So let's say I have a divided by, okay, 1 plus square root of b, okay? And then they ask you, rationalize the denominator. So what are we going to do there? Okay, we're going to multiply by the conjugate. So now, listen and listen very carefully. If we have two terms that are adding in the denominator like that, okay, the conjugate that you're going to multiply with is this same number that we can see here, but we are going to change the sign that we have between those two numbers. Okay, so there we have a plus. It means that our conjugate will be, okay, we're going to multiply by the conjugate. So our conjugate of this guy here is just this same number, but we change the sign in between here. So we're going to say 1. Here we are the plus. So here we're going to write minus and then root of 5. Okay, and then we multiply this same 1 minus root of 5 even with the what? The numerator. So we notice that what we have here is just a what? This is a 1, guys. Okay, this is a 1. We are dividing the same thing. All right, so that's the conjugate. Okay, so let me write some expressions here. So for example, I have, let's say 1 minus root of 2. So what is the conjugate of this guy? The conjugate of this guy will just be 1 plus root of 2. So notice that we are just changing the sign in between. Okay, what if I have root of 5 minus 1? What is the conjugate of this root of 5 minus 1? Okay, so we just change the sign in between. We're going to say root of 5 and then plus 1. Okay, what if we have, let's say we have root of 5 and then minus root of 2. Okay, so here we notice that we have two sides or two square roots. Okay, so your conjugate will just be the same thing. Okay, so you just write root of 5 and then plus root of 2. So in short, you just change the sign that is between those what? Two numbers. Okay, what if we had, let me say, root of 3 and then plus 5? What would be the conjugate of this root of 3 plus 5? The conjugate will just be root of 3 and then minus 5. Okay, so we just change the sign in between there. Okay, so once we change the sign there, okay, it means we can multiply with that conjugate. Okay, so now when multiplying an expression by its conjugate, okay, you don't have to waste your energy on expanding. Okay, so let's finish this one here. So this one here, the a, if we multiply by 1 minus root of 5, we're going to have a minus a root of 5, right? We're expanding the a to the 1 and to the minus root of 5. And then we're going to say divided by. So here now we have 1 plus root of 5. Okay, this is 5. 1 plus root of 5, and then here we have 1 minus root of 5. So if you're multiplying an expression by its conjugate, okay, you don't have to waste your time expanding the whole expression. You're just going to say the answer is 1, you square it, and then you say minus, and then you put the other number there. So we had 1 and root of 5 here. So we're just going to say the first number squared, and then the second number squared like that. Okay, so this is going to give us a minus a root of 5 divided by, here we're going to have 1, and then this root of 5 squared. So root of 5 squared is the same as root of 5 multiplied by root of 5. So it means this is going to give us what? It's going to give us just 5. So this will be minus 5. Okay, so your answer will just be a minus a root of 5 and then divided by 1 minus root of 5, which will just be a minus 4. All right, so if you don't want to use this shortcut, you can still expand this the normal way. Okay, so we have this 1 plus root of 5, and then we also have 1 minus root of 5. So if I'm expanding this to this, okay, I'm going to say 1 multiplied by 1 is going to give me 1. 1 multiplied by minus root of 5 is going to give me minus root of 5. And then we go to the root of 5 now. So root of 5 multiplied by 1 is going to give me plus root of 5. And then positive root of 5 multiplied by minus root of 5 is going to give me minus, okay? And then I have root of 5 multiplied by root of 5, which will just be what? 5. So we see that the middle part there, if you multiply an expression by its conjugate, the middle part there always cancels. So the minus root of 5 plus root of 5 will cancel. Means here we're just going to remain with 1 minus 5, which will give us a minus 4. Okay, so you can see we have gotten the answer, the same answer here when we use the shortcut, or even here when we expand it. Okay, so I've taught you the shortcut. As long as you're multiplying an expression by its conjugate, okay, just get the first number, square it, and then say minus, you get the second number, and then you square it. Okay, so those are the rules that we are going to be working with when we are rationalizing the denominator. All right, so any questions there, guys, before we solve some example questions? Any questions? All right, so let's look at the example questions now. So next here, I have some questions, okay? We are going to use the rules that we learned, okay? So we are going, first of all, to use the laws of Surds that we learned to simplify all these that we can see here. And then we are also going to rationalize the denominator on the questions on the next page, okay? So the first one there, A, we have root of 8 plus root of 40. Okay, so root of 8 plus root of 40, we can simplify this. Okay, so we're going to say this is equals to, so we know that this 8 here, okay, can be written as 4 multiplied by what? 2. Okay, and then this 40 here, in what way can we write it? Okay, so that we simplify it. Okay, so let's do that. So the first here, the 8 here, we know that it can be written as the square root of 2 multiplied by 4. We know that 8 multiplied by, 2 multiplied by 4 is going to give me back the 8. Okay, so by that first rule that we said, if you have square root of A multiplied by square root of B, this is the same as square root of AB. Remember this rule? That's what I've used on this first 8. And then even this one here, okay, the 40 there, we can also try to simplify it. Okay, so we're going to say plus, and then the square root of, okay, so we want to pick two numbers, okay, that can give us a 40, such that those two numbers have a perfect what? Have a perfect square root. Okay, notice how we picked the numbers for this 8 and for this 8 here. We picked 2 and 4, and we know that this 4 here has a perfect what? Square root. So for this one here, for the 40, we're going to pick a 4 and a what? A 10. We know that 4 multiplied by 10 is equals to 40, right? So I'm going to write 4 multiplied by 10 here. Okay, so from here, what are we going to have? We're going to have that this is equals to, okay, I can now separate these two here using this rule. So I'm going to say this is the square root of 2 multiplied by the square root of 4, and then plus, even here I can separate, it will be the square root of 4 multiplied by the square root of what? 10. So this is what I have. Okay. All right, so now let's simplify. So this here will be, what is the square root of 4? Square root of 4 is 2. So 2 multiplied by the root of 2 is going to give me 2, and then root of what? 2. And then we're going to say plus. Here it will be the square root of 4, which is just 2, and then the root of what? 10. Okay, so we've simplified this guy here. So any questions there? Any questions there, guys? Okay. All right, so okay, so in fact here I've seen we can simplify this further, okay, because that root of 10 we can adjust it. Okay, we can adjust that root of 10 there. So that root of 10, let me write it on the side here. So the root of 10, we can also put it in terms of the root of 2. these two here, so that we have similar numbers on both sides. So this root of 10 is going to be equals to root of 5 multiplied by 2. Okay, and then we can separate the roots. It will be root of 5 multiplied by root of 2. Okay, so that root of 10 is the same as root of 5 multiplied by what? Root of 2. So let's put it there. So it will be, this will be equals to 2 root of 2 plus 2 root of 5 multiplied by root of 2. So now we have a similar surd here and there. So we can factorize it. So this is going to be equals to, okay, if I factorize the root of 2, I'm going to remain with 2 here. And then plus, if I factorize the root of 2 from here, I'm going to remain with 2 root of 5. And then outside there, I'm going to have the root of 2. Okay, so we can simplify it further to this. All right, so any questions there before we solve the second one? All right, so let's look at the next one then. If there are no questions. Okay, so B, we have root of 20 plus the root of 45, and then plus the root of 125. So we can simplify these lads, okay, these surds I mean, by finding two numbers, okay, such that one of them have a perfect root, okay. If we can find those two numbers, then we can simplify this. Okay, so we start with the root of 20. We know that the root of 20 is the same as 4, okay, multiplied by 5. Okay, this 20 here, you get it by multiplying 4 and 5. So we can write the root of 20 as the root of 4 multiplied by 5. Then we're going to say plus, we have the root of 45 here. So the root of 45 is the same as the root of 9 multiplied by 5. So we know that 9 multiplied by 5 gives us 45. Okay, so we can replace it with that and then plus the root of 125. So the root of 125 is the same as 25 multiplied by 5. So we're going to say 25 multiplied by 5. So 25 multiplied by 5 is the same as 125. Okay, and then from here we're going to separate the square roots. So it will be the square root of 4. Okay, we have the square root of 4 here multiplied by the square root of 5, and then plus the square root of 9 multiplied by the square root of 5, and then plus the square root of 25 multiplied by the square root of what? 5. Okay, so we can see what we have there. So from there, we are going to say, what is the square root of 4? The square root of 4 is 2. And then here we have the square root of 5. And then plus the square root of this 9 will be 3. And then we have the square root of 5. And then plus, what is the square root of 25? It's 5. And then we have the square root of what? 5. So we can see now that all these numbers that we have square root of 5, square root of 5, square root of 5. So it means we can add them because they are common. They have a common surd there. Okay, they have a common surd. So I'm just going to add the number. So 2 plus 3 plus 5 is going to give me 10. And then I have root of what? 5. Right, so this here will be our answer. Right, so any questions there, guys? Any questions from there? Right, no questions. I'll go to the next one. Okay. All right, so the next one there is saying C, we have the root of 48 divided by the root of 16 plus the root of 27 divided by the root of 12. Okay, so how can we simplify this? Okay, how can we simplify this? Okay, so we look at the first one there, which is the root of 48. Okay, so we know that we can write 48 as 16 multiplied by 3. So I'm going to put that there. So it would be the root of 16 multiplied by what? 3. That would be the root of 48 there. And then divided by, we have the root of 16 down there. And then plus this 27 here. We know we can write it as 9 multiplied by what? 3. So I'll write that. So it will be the square root of 9 multiplied by what? 3. Then we're dividing this by 12. 12, we can write it as 4 multiplied by 3. So that would be the square root of 4 multiplied by what? 3. And then now let's separate those sides. So it would be the square root of 16 multiplied by the square root of 3 plus the square root of 9 multiplied by the square root of 3 again. And then I'm dividing all this. No, not all that. Okay, each one has its own denominator. So I'm dividing this.
Sir?
Yes?
Yes, I wanted to ask, why haven't we simplified the 16?
Okay, so the 16 there, I can see a 16 on top there. So even if you simplify it, or if you don't, it's still going to. So like when you look at this 16 here, it already has a perfect square root. So there's no need to simplify it. It already has a perfect square root.
All right, sir.
Yes, okay. But when you look at this 49, 27, and 12, they don't have a perfect square root. No wonder we are simplifying them into all these. All right, so this is what we have divided by the root of 16. And then here we're going to have divided by the root of 4 multiplied by the root of what? 3. So from here now, we see that here, okay, we have the root of 16 divided by root of 16 multiplied by the root of 3. So it means we can cancel out the root of 16, cancel out the root of 16. We're going to remain with what? The root of 3 over 1 here. And then there, okay, what do we have? We can cancel out the root of 3. So here we're going to cancel out the root of 3, cancel out the root of 3. So we have the root of 9. Okay, what is the root of 9? So I'm going to write plus. The root of 9 here will just be 3. And then divided by, what is the root of 4? The root of 4 is 2. So this is the expression that we now have. Okay, so we can add that. So it will be 2 in the denominator. 1 into 2, it will be 2. 2 multiplied by root of 3, it will be 2 root of 3. And then plus 2 into 2, it will be 1. 1 multiplied by 3, it will be 3. Right, so this one here can be your answer, or even you want, you can leave it here. Okay, if you want, you can leave it there. Both of them are correct. Right, so that's it about simplifying surds. Okay, so you just have to know the formula, I mean the laws, okay, the ones I highlighted at the beginning of the class. So you just have to know those laws, and then you'll be able to simplify any surd that you've been given, okay, provided you know two numbers that can represent that number under the root. Okay, so it's a trial and error method. Okay, you try these numbers, see if they work. You try those numbers, see that they work. All right, so once we're done with the simplification, now we can go to rationalization. Okay, so these are the questions that we have on rationalization. So they're saying rationalize the denominator in the following. Okay, the first one that we have is 5 divided by the root of 5. So I said if you have one, okay, a single side in the denominator, okay, we just multiply by the same side. Okay, it becomes your conjugate. So we're going to multiply that by the root of 5. And then even on top here, we're going to multiply by the same. So this is going to give you what? 5, and then root of 5. And then down there, it's going to be root of 5 multiplied by root of 5. It's going to give me a 5. So we see that this 5 can cancel out with the 5 on top. So you cancel this and this. So your answer will just be what? Root of 5. So that's the answer on the first one. If you have any questions, feel free to ask. How that go? Otherwise, I go to question B. So question B, we have 4 divided by 2 minus root of 3. So here now we have a surd, okay, being subtracted from another number. Okay, so it means our conjugate there will be, okay, we're just multiplying by the conjugate. So it will be 2 plus the root of 3. Even on top there, 2 plus the root of 3. Okay, so this is going to be equals to 4 multiplied by 2 is going to give me 8. 4 multiplied by the root of 3 is going to give me 4 and then root of 3. Then divided by, remember what I said when you are multiplying two numbers that are surds? I mean that are conjugate of each other, okay? Because this one, the 2 plus root of 3 is a conjugate of this. So if these two expressions are conjugates, just get the first one, which is 2, write it, and then say squared, and then minus the other part, which is the root of 3, you also square it. Okay, so this is going to give us 8 plus 4 root of 3. And then we're dividing this by, what is 2 squared? 2 squared is 4. And then minus the root of 3 squared. It means we have root of 3 multiplied by root of 3. This is just going to give us 3. So I'm going to write 3 there. Okay, so it means the expression that we now have is 8 plus 4 root of 3. And then 4 minus 3 is just equals to what? 1. So our final answer will just be 8 plus 4 root of what? 3. So this here will be our final answer. All right, so that's how we solve our question A and B. Okay. Let's look at question C. So on question C, we have 2 minus the root of 7 divided by the root of 7 minus 4. So let's multiply by the conjugate. Okay, so the conjugate is this same expression here. We just change the sign in between there. So we're going to say conjugate is the root of 7 plus 4. Then divided by, here we're going to have the root of 7 again plus 4. So let's multiply now. So on top here, these are not conjugates of each other. So we have to expand them normally. So it will be 2 multiplied by root of 7. That would be 2 root of 7. Then 2 multiplied by 4. That would be plus 8. And then now we go to the minus root of 7 here. So minus root of 7 multiplied by root of 7 is going to give me minus 7. And then minus of root of 7 multiplied by 4 is going to give me plus. It's going to give me minus. That would be a minus. So minus 4 and then root of what? 7. All right. And then we divide this by the multiplication of this guy with its conjugate. Okay. So if they are conjugates, just write the root of 7, square it, and then minus, we have 4, and then square it. Okay. So on top there, we can simplify what we have. So we have 2 root of 7, and then here we have minus 4 root of 7. So since we have the same surd there, we can combine those two, okay? So the ones on the middle will be 8 minus 7. That will give me 1. And then 2 minus 4 root of 7 is going to give me minus 2 root of 7. Then divide this by the root of 7 squared is going to give me 7 minus, what is 4 squared? 4 squared is going to give me 16. So what I have now from there is equals to 1 minus 2. Okay, 1 minus 2 root of 7 divided by, okay, here I have 7 minus 16. So 7 minus 16 is going to give me minus 9. Okay, so it means our final answer, you can leave it here if you want. You've rationalized the denominator. If you want, you can say divide by this minus 9 into the 1 and this minus 9 into the minus 2 root of 7. So you can also represent your answer like this, minus 1 over 9, and then plus 2 root of 7 divided by what? 9. Okay, so you can represent it like this or like that. Both of them are correct. Okay, so any questions there? All right, let's look at another one then. Okay, so we are on D now. This is D there. So D, we have 3 plus 2 root of 5. Then divide this by the root of 2 plus 3 root of 5. So we're just multiplying by the conjugate. Okay, so the conjugate will just be the root of 5. Okay. the root of 5 minus, so we are just changing this sign here, so minus 3 root of 5, then we divided by the root of 5 minus 3 root of 5. Okay, so let's multiply. So what we have on top there will be 3 multiplied by root of 5, which will be 3 root of 5. Okay, then 3 multiplied by minus 3 root of 5 is going to be minus 9 root of 5. And then now we go to the 2 root of 5 here. So 2 root of 5 multiplied by root of 5 is going to give me plus 2. Okay, and then root of 5 multiplied by root of 5 is going to give me what? 10. I mean, it's going to give me it's going to give me 5. I've multiplied already in my
Sir,
mind.
sorry.
Uh-huh.
Here, the denominator is root of 2 plus 3 root of 5, but you've written root of 5 plus 3 root
Oh,
of 5.
yeah, I see. Oh, I thought it was a root of 5. Let's change it. Let's change it. Okay, yeah, but the process is the same. So I have the root of 2 here, right? And then I have 3 and then root of 5. Okay, so the conjugate here will just be the root of 2 minus 3 root of 5, then the same thing above here. Okay, so it's the same concept. I just wrote a wrong number there. So let's multiply still. So 3 multiplied by the root of 2 is going to give me 3 root of 2. Then 3 multiplied by minus 3 root of 5 is going to give me minus 9 root of 5. And then 2 root of 5 multiplied by root of 2. Okay, it's going to give me plus 2 root of 5 multiplied by root of 2. Okay, and then this root of 2 root of 5 multiplied by minus 3 root of 5 is going to give me minus 6. And then this root of 5 and this root of 5 is going to give me a 5, like that. Then we are dividing all this by the product of their conjugate. So the conjugate, we just get the first one, okay, root of 2. We square it, and then we say minus. We get the second one, which is 3 root of 5. We also what? Square it. So that's what we have. So let's simplify what we have on top there. Okay, so on top, we have 3 root of 2. And then we have minus 9 root of 5. And then plus 2. Okay, and then we have, okay, so this one we can multiply. So root of 5 plus root of 2 is just going to give me root of 10. Okay, and then at the end, they are going to have a minus 30. Then we're dividing all this by what is the 2 root of 2 squared there? It's going to give me 4. Then minus what is the square of 3 root of 5? So square of 3 root of 5 is going to be 9. Okay, and then when I multiply this root of 5 multiplied by root of 5 is going to give me a 5. Okay, so what I end up having is 3 root of 2 minus 9 root of 5 plus 2 root of 10 minus 30, and then I'm dividing all this by 4 minus 9 multiplied by 5. So what is 9 multiplied by 5? So that would be 4 minus 9 multiplied by 5 is 45. So it means I'm going to have minus 41. Okay, so that will be your answer here. You've rationalized the denominator. Okay, we can't see a root in the denominator there. All right, so that's basically it on rationalizing the denominator. Okay, you can just use whatever you have and then just multiply by the conjugate, and you get rid of the square root from the denominator. Then that would mean that you've rationalized the what? The denominator. Okay, so these others, you can try them out. So you try to rationalize the denominator here. You also try to rationalize the denominator there. All right, so I also have some more questions here. Rationalize the denominator. So you just do the same stuff that we are doing, okay? And then here there's an assignment. So this assignment, you can try it out, okay? But I already solved these questions, okay? They already solved these questions. They are there on my YouTube channel. I also shared them in the group, okay? So you can try them out and then you check if what you're doing is correct. You check using my YouTube channel. These videos are there. I solved this one, all of these, I solved them. All right, so any other questions, guys, about rationalizing? Any questions, guys? All right, so if there are no questions, then we end here for today. Okay, we end here for today.
So are we still having a class at 22?
Ah,
Are we still having a class at 22?
yes. So at 22, we are going to look at logs.
Okay.
All right.
Okay, it's on that I received the link late, so the concept I've really missed it. So don't know
Okay.
if they will be recorded.
Yes, we always record our classes. So I'll share the recording.
Okay, thank you, sir.
Okay, you're welcome.